All right, folks, what I'm modeling now is how you might choose to use the 5 practices in your class doing this type of problem. The 5 practices are listed on slide 42 if you wanted to take a quick peek at it. Smith and Stein do a great job of taking apart a complex issue of how do I have a great math discussion and put them into these 5 steps. I've already made sure that the task was open-ended and had lots of different ways of solving it. I anticipated already. I found 8 ways that I am looking for the sorts to be captured in our discussion. I monitored. As you notice, I was in your breakout rooms watching these slides develop and figure out like which ones do I want to select for a whole group conversation and in what order do I want to do that. And now we're going to connect. We're going to actually have the whole group conversation. I have about 15 Post-it notes in front of me with different orders on who's going to go first, second, third. I'll be very specific with your question, and we're going to go through this continuum of different representations. So let's start. And we're going to start on slide 26. So if we can all please come on up to slide 26. Group 1, I know you had several different sorts that you were thinking about, but would you please share what was your idea for slide 26?
Well, when I first heard the challenge about taking these triangles and splitting them up into boxes, I'm out in California, so it's still early in the morning out here, and my brain went abstract. It was like, hey, this will be like Tetris, and which is a game I played as a kid. And so when I presented it to my team, they're like, oh, that's cool. Let's move them around so we can put them in different boxes. And we ended up with 4 different quadrilaterals.
Very cool and nice addition to quadrilateral lessons. Alrighty, let's take a look at slide 30. And group 3, I know you had also thought of many different ways of sorting these, but what does slide 30 mean to you?
I can jump in and share. So when we first looked at them, one of the first things we noticed was that they were just kind of varying sizes. So we kind of thought about how they could be sorted into small, medium, and large. And we ended up identifying what we thought was large first and then small next. And then we kind of whittled it down to what we thought was medium.
Excellent. So we've got some of these very early geometric sense making here. And I have a feeling that group 1 used a little bit of this in creating their Tetris pieces. So move between slides 26 and 30 and see how you might have used size when connecting them like Tetris pieces. If you have an idea of why these share a similar strategy, go ahead and type that in the chat box or turn on your microphone and let us know how size might be useful in these Tetris pieces. So Bridget mentioned that each Tetris piece has 1 or 2 big ones and then some small ones to fill in. Absolutely. In thinking of size, let's go down to slide 38. I'll try and type these in the chat box so you can keep the slides straight. Join me on slide 38. Group 4, tell us, were you thinking the same way or a little differently in your size categories?
Maybe someone, Dave can tell us here too, but I think it's kind of the same. Large or big scones area-wise, medium scones, and small ones.
So you notice the terminology used here is a little different too. Why might the previous slide on slide 30 use terms like big, medium, small? And in group 4, all of a sudden we heard the word area. How might those be the same? And are they always the same to say big, medium, small? Is that always related to area?
I know sometimes we were looking at the height of these triangles or the base. So it could be some linear measurement like a height, or areas more two-dimensional.
Interesting. Okay, so we could look at height, a one-dimensional thing, or area, two-dimensional. And Caitlin also says that they're up for a little interpretation, which is why our slides do look a little different. Come join me on slide 40. Group 4, what's going on here? Slide 40.
As she was saying, we were looking this time more at the heights of them, and I forget who it was that said it, but we noticed that like G and H went from the bottom all the way to that middle part of it, so their heights were the same, and we were looking at which ones had similar heights like that.
And height is a really interesting thing to look at. Going back with what Caitlin said about up for interpretation, would any of you guys think to maybe categorize these a different color by the way you saw the height?
Well, from a geometry standpoint, the height is technically defined from it has to be from a vertex and perpendicular to the base. So I agree that G and H would have the same height, but probably not N and I, because they would have significantly shorter heights by the definition of being perpendicular to the base.
So now we're getting into some more sophisticated definitions. What about E? I mean, if you see the square outline that I made to make this shape, then it's pretty big. But does that fit Kate's definition of big height now?
It depends on which way you're measuring it. If you're going from the vertex on the right to the hypotenuse, or not the hypotenuse, but the long side on the left, you'll be pretty short. But if you're going from the vertex on the bottom left to the small base on the right, and you'd have to draw a dotted line going down, that would be a pretty big height.
Ah, so now we might have reasons to take into account all three of the heights, bringing our math lesson to a much more rigorous standpoint. Several of you all decided to sort by things that are pretty common in 5th through 8th grade. And if we look at slide, let's see if it's still group 4. Yes, okay, if we can go to slide 33. And group, go ahead and tell us, how did you think about this?
So this one we were thinking about the ways that we classify triangles, I guess. And so it was, we're on 33, right? So the scaling, isosceles, and equilateral. So whether or not they have all equal sides, two equal sides, or no equal sides when measuring the length of the sides.
Great definitions there. Let's compare that to slide 35. Group 4, what did you think about for slide 35? And everyone else is thinking, how's 33 and 35 similar and different?
So they were looking at the lengths of the sides. We were looking at the angle measures. I believe so we looked at right angles, obtuse angles, and acute angles in our 3 groups.
So it makes me wonder, could we include, could we sort things by angles and sides and put them together? Is that a possibility? So let's take a peek at a slide. Slide 41. Is it possible to have a right scalene triangle? And is it possible to have a right isosceles triangle? If you think so, would you just paste a picture of our triangles in there? We don't need any words. All we need is an example of the picture. And you can resize it and just put it right there in the box. All right, super. What about if we were to get into acute triangles? Can we put some in there? And I realize it's a little chaotic with everyone, but let's see if we can do it. And as this is happening, if you are someone who can communicate well in words, where some other people might be more, find the pictures more accessible, tell us in words why are these things possible? And are they always possible? Are there some rules that make more sense than others? Go ahead and turn on your microphone if you're making some sense of this.
Well, the angle measure is related to the lengths of the sides. So, for example, we can have an acute and equilateral triangle, but we can't have a right and an equilateral triangle because you can't. The 3 angles have to add up to 180. And so, with a right angle triangle, you would have one angle being 90, and then the other 2 would have to be smaller. The sum of the other 2 would have to be smaller than 90. So the other 2 sides could not be the same length as the side that was opposite the 90-degree angle, if that made sense.
Yeah, I think it does. But I'm not convinced. I kind of think I could make a triangle with 3 right angles. I just need some time. Is anyone else there with me? What might you tell me to do to try and do that? I think I might just need some time.
The last time I taught geometry was 12 years ago, but I remember having kids who wanted to do it, and so just let them try it, and they realize they can't. They can definitely draw 3 right angles, but they can't connect the sides without making a 4th right angle or another angle in general.
Right, so I can go ahead and put these lines in. I just try to make a little polyline tool there. I can try and make 3 right angles, but I'm not going to be able to turn that into a triangle. And that is interesting, and that is worthy of discussion. How about these obtuse ones? Do we have any examples for those 2, or are those also impossible?
You can't have obtuse and equilateral.
Yeah, but why not? I feel like if I just have more time, I could do it. What's going on there?
It goes back to what I can't remember who spoke first, but when they were talking about how the angles add up to 180, if you have an obtuse angle, then all of the angles would have to be larger than that 90 degrees, and then they wouldn't equal 180.
Very cool. All right, folks, that's some different ways that you can choose to have your whole group discussion. Again, it's very interactive with people being able to add to slides. It also capitalizes on different students' way of wanting to communicate. Some people, Bridget did a great job of writing in the chat box there. Some people like to use audio. Some like the shapes on the page. But every student was able to have a voice and participate in a way that they felt most comfortable. So that's how I use the 5 practices in my class. I have some other questions on slide 43 that I really this was one of the main focuses of my lesson. I wanted to talk about possible combinations. And if the conversation led there, a secondary idea was this idea of height and area, and are they related, and in which ways are they related? So that's kind of another avenue I could have gone down. On slide 44, I often ask teachers to think about when they exercise and they stretch. You might stretch way up high if you stand up, and then you could try and stretch way down to your toes. And if you shake it out and you do it again, you're likely to stretch farther the second time and farther the third time. Depending on how many classes you've come to this Mather Days session, I'd like you to go ahead and take a text box on slide 45 or 46 and tell me what grade you're in and how you could do this problem in that grade, and then stretch up. If you teach 5th, think about 6th, 7th, and 8th. Where are students going? If you teach 5th, go ahead and reach down to 4th, 3rd, and 2nd. Think about what are the prerequisite skills, the developmental skills we want our students to have so that they can reach the rigor that's required in your grade level. I'm already seeing 2nd grade, 4th, 5th, 6th, 7th. For those of you teaching high school geometry, we also have important concepts and combinations like side, angle, angle. I wonder how you could use this to get them to be thinking about ways of finding angles and side measures. Thank you for sharing your expertise and your grade levels. The rest of the time, I'm going to spend looking at extra slides and templates and answering questions in the virtual parking lot. It was an absolute pleasure to work with all of you today on our Mather Days. There's already a Mather Days for next Saturday available if you are interested to sign up. I encourage you to take these strategies, take 1 or 2, and start nice and slow. As you introduce it, see what your students can do and monopolize on that. The slides below are all here for you. Slide 47, I had some middle school teachers who really wanted a quadrilateral sort, so there's one there for you ready to go. Slide 48 is here for anyone who likes a little bit more structure in the ways that their students are presenting examples and non-examples. I prefer a little chaos. I think that more math emerges when it's messy, but I realize that we all have different pedagogical strategies and different standpoints comparing to our audience. Slide 49. If you are not sure that your students can do the Google, please don't assume that they can't. Our students are amazing and they can learn quickly. I suggest giving this scavenger hunt to your students. The scavenger hunt is very purposefully developed to make sure that they can do things like copy paste, take a picture on their cell phone and upload it, change the color of fonts, and so on and so forth. Templates from this session are available below, and if you click that link, you'll get all of my templates from all sessions. Finally, I'm going to end down at the virtual parking lot, slide 67 or 68. If you would go ahead and put your questions on that slide, I will answer them as they come in. In addition, if you would like access to videos as soon as they are published, you can subscribe to my YouTube channel and you'll get an email whenever a new video is out. You can follow me on Twitter and find out the first about new sessions that are offered. You can send me emails, and PD registration is the yellow link. You can sign up for Mather Days next Saturday. You can also sign up for sessions 1 and 2, which are just general strategies for any grade level. Session 3 focuses more on English language learners, sorts, and matching. And session 4, which is not out yet, but just be aware is coming, is all about classroom management and accountability. So those things are coming up. What are the important things to consider when selecting a good task? I feel that I need to update how much is doable in an online class. When I think of a rich task, I specifically think of a task that can be accessed 2 grade levels below the grade level that I'm thinking of focusing on and 2 grade levels above. Usually when I create a task, it's almost too specific. Like I'll start off with this one thinking, hey, let's put all these triangles in order by angles and order by sides. And I'll give them this worksheet to do where they do that. And then I realized that only some students could access that. So I loosened up my guidelines and my restrictions, and I said, well, what about if it's any sort? But then I don't just want to focus on, some of them. I really want to get to sides and angles. So I just developed my math talk around that. If you're looking for what's doable in one class, I usually find 1 task per hour is doable. If you try to do any more than that, you're going to be rushing through it. And you probably heard me rush through this one. I wasn't modeling how much time to give students. I was modeling how to do a math talk and get some of those key components in with the time that we had. What kind of mic headset equipment do you use? I use a Bluetooth Logitech. You can use corded ones too. Here's what you want to look for. Unidirectional microphone. There's going to be a little microphone that sticks out of the bottom of it, and it catches your voice and not, in my case, my 1st and 2nd grader who are playing Legos in the background. All right, folks, if you have any other questions, please let me know. Otherwise, thanks for spending your Saturday with me. I hope these slides are useful and you can just take them and drop them right into your lesson.